So this section is going to be over section 6.7 from the book, which deals with financial models. In this section, we'll go over a number of formulas dealing with how to save, spend money, depending on interest values. First, let's have a couple of definitions so we can make sure we're all on the same page. Interest is the money that is paid for the use of money. Interest can be paid or earned if you are borrowing money from the bank as a loan, then you must pay back the bank with added interest for the agreement. If you are giving the bank money, such as a savings account or stocks or bonds or CDs, for example, then the bank will give you interest for that agreement. The total amount borrowed or deposited initially is called the principal. Some people call this the present value. The rate of the interest is expressed as a percent, is always the amount charged or earned for the use of that principal for a given period of time. The time is usually in years. If the principal of P dollars is borrowed for a period T years at an annual percentage rate of R expressed as a decimal, then the interest I charged to that account is equal to this simple interest formula, where the interest earned is equal to PRT. The interest earned is equal to the principal times the rate as a decimal times the time in years. So let's go over one simple interest problem. Find the interest earned from a CD, certificate of deposit, agreement of $10,000 with an APR of 4.3% for 1 year. How much will your ending balance be? So first, let's find the interest earned. PRT. P is the principal or the down payment made or the amount deposited into the bank, times R, which is the interest rate as a decimal, times the time period of 1 year. $430. So the interest earned on a $10,000 deposit in a savings account of 4.3% for 1 year will get you $430 extra in interest. Now, if you wanted to find the future balance, in other words, how much will my account have at the end of 1 year? The future balance, or the amount, is going to be equal to the amount of the original principal plus the interest that was added into the account. So it's going to be $10,000 plus the $430 extra that you earned. So you'll have a total of $10,430 in your account at the end of this time period of 1 year. So sometimes the questions might ask you for how much interest did you earn? Sometimes the questions might ask you, what is your account balance at the end once your interest has been added in? So be careful with the questions and how it is worded so you know which answer to give. Now, what if I change that and I said, let's go ahead and save for 4 years. So not just 1 year, we're going to save this amount for 4 years. So interest is going to be times 4, or we can just use the interest formula again, as we did previously. The only thing that would change in this formula is the time period. Instead of putting in 1 year, we're going to put in 4 years. And you're simply just going to see that this interest has been multiplied by 4. So it's $1,720. So you can see that our future balance, or the amount at the end of the 4 years, is your principal plus your interest, which is going to yield us $11,720. So simple interest is fairly easy. You just have to use the annual percentage rate for however many years you plan to save. You're going to save the same amount of interest every single year, $430 for however many years you plan to save. Most banks use something called compounding interest. This is when your interest earned or due is added back into the principal so that the new interest computed at the end of the next period is based on the principal amount, which is your original principal, plus your added interest. And so the interest is said to have been compounded. The compounding interest is interest paid on the principal plus the previously earned interest. So for example, in this last example, at the end of year one, we had $10,430. In a simple interest account, you're only earning interest on the original $10,000 for every year you have this money in your account. But in a compound interest, in year two, you'll earn interest on this total amount, which is the amount you put in plus the amount of the interest, since this is the total amount in your account. Theoretically, that $430 is yours. So we're earning interest on the new interest that has been added into the account. So every year your interest is getting bigger and bigger and bigger because the amount in your savings account is getting bigger and bigger and bigger. So compound interest will always earn you more money than a simple interest account will. The amount A after T years of saving of a principal P invested at an annual interest rate of R expressed as a decimal compounded n times a year is given by the following formula. Compounded n times a year means how many times you plan to dole out the interest to the customer. So for example, if you're only going to do it one time a year, annually, n would be 1, meaning one time a year. If you plan to do it monthly, n would be 12. If you plan to do it daily, n would be 365. If you plan to do it quarterly, n would be 4 times a year. If you plan to do it semi-annually, n would be 2. So those are the most common ones that you can come up with. I suppose there could be bi-weekly, which means every other week, kind of like how you get paid with your paychecks, and that would be 26. That one's not used as often. So let's run through some examples of using this formula on the next page. I think I got my pages a little backwards here. There it is, it's on the back side. Okay. So let's first find the future balance from a certificate of deposit agreement of $10,000. So it's the same principle as the last example, but this time we're putting it into a certificate of deposit and it's saving for the same 4.3%, but this time we're going to compound it. Okay. So we have to use the compounding formula. The compounding formula says that your future balance is equal to your principal times 1 plus your interest rate divided by the number of compounding periods to the n times t time period power. So let's see, principal is $10,000 times 1 plus R, the interest rate is 0.043 divided by yearly. We're going to compound it just yearly. So that means just one time a year to the power of 1 times. We're going to save this money for simply just 1 year. So we're going to take that just to the first power there. So let's go ahead and calculate this and find out how much money we will have at the end of this agreement. So let's put into our calculator $10,000 times 1 plus 0.043 divided by annually to the power of 1 times 1. So you see, we're going to have $10,430. Now the question asked us though, how much interest did you earn? So for this example, since this equation gives us the future balance, to find the amount of just the interest, you take your future balance and subtract out your principal. So the $10,430 minus the amount that I deposited at the beginning means that we earned $430 in interest. And you can see that that is comparable to the simple interest formula. Compounding once a year for the first year is going to be the same as compounding annually in a compounding formula. But as soon as we reinvest this for the second year, this interest would go up to something higher than $430. We will do an example of that next. So let's go ahead and recalculate this, but let's do it for monthly. So the only thing that's going to change in this formula is the number of compounding periods. So instead of it being 1, these numbers are going to change to 12 because we're going to compound 12 times a year. All right, so my future balance is going to be $10,000 times 1 plus 0.043 divided by 12 to the power of 12 times 1. So you see, we're going to have $10,438.58. So the amount of interest I earned is obviously going to be just the $438.58. So you can see the difference in the interest. I earned $8 additional interest because I'm compounding more often during the year. Let's go ahead and do it one more time. This time we will do it daily. So again, we're just changing that N from 1 time a year to every single day, meaning N would be 365. So you see, we're going to have $10,439.35. So the amount of interest is just going to be the $439.35. So you can see it has increased even yet again. So in the last question, what did you notice? Well, we noticed that the higher the N, or in other words, the more often you compound an account, the more interest you earn. There is one more type of compounding, and that's called instantaneous or continuous compounding. When the interest on a compounded account is compounded every instantaneous second of the day, meaning it's just a continual clock running of continuous compounding. We call this continuous compounding. So the amount A after T years due to the principal P at a rate R is given by the following formula. The future amount is equal to P times E to the RT power. So let's find the exact same example that we did up above, but let's do it instantaneously. So I'm going to expect that instead of compounding it once a year, 12 times a year, 365 times a year, that doing it every single second of the day is going to be a number that's going to give me even higher than $439 worth of interest. because we're compounding it instantaneously all day long. So let's see what happens. Our future balance A is equal to P times E to the RT power. So our principal times E to the power of our rate times T power. So let's go ahead and plug that into our calculator and see what we get. $10,439.38. So you can see the amount of interest that we'll earn is $439.38. The amount of interest earned is going to be $439.38. And how does that compare to the numbers up above? Well, very close to daily compounding, but still the most of all of the options. So to wrap that up, of all of the options so far, which of the interest accounts earns you the most? Continuous compounding. Continuous compounding. Okay. So let's go over some other ideas, making wise choices. What if you had a couple of different accounts that you could decide where you wanted to put your money, and you need to decide which one was going to be the best option for you. So for example, which of these interest-bearing options would you invest your $10,000 into from Aunt Edna? So Aunt Edna gave you $10,000, and you need to decide which of these four options, there's four options here, which of these four options is going to give you the best option for saving money. So what we're going to do is we're going to figure out each of these and figure out what the future value and or interest would be. So the first one is simple interest. It says Uncle Joe says he will hold on to your $10,000 and he'll give you a 4% return on your investment. So using simple interest, right? Simple interest, the amount of interest earned on that account is equal to PRT, the amount of the principal times the rate, which he's going to promise me 4% for the next 8 years. So Uncle Joe is going to promise me $3,200 in interest. Chase Bank, where you do your local banking, has a savings account. And this is a compounding account. So we're going to find our future balance, which is equal to P times 1 plus R over N to the N times T power. So we're going to save $10,000 times 1 plus the interest rate. The interest rate is 0.4%, and that's pretty typical of a savings account. Savings accounts do not yield a very high return. It's a very slow return meant for small amounts of savings. It's definitely better than a checking account, which gives you nothing in return, but this is less than 1%. If you're really looking to save money, there are other options which we'll get into. But savings accounts are better for putting money in that you want to have access to quickly, like if your car breaks down, or doctor bills, or Christmas funds, things like that that you want access to every year just in case. It's accessible very easily, and there's no penalty for taking your money out. So this is a good way of saving money for money that you want liquid or very accessible. So we're going to put in the interest rate. Now, remember, this is 0.4%. So as a decimal, we need to move that 2 times to the left. As a decimal, that is actually 0.004. So be careful with that one. We're going to compound it only annually, and we're going to save this for 8 years. So let's see what our future balance is going to be on this account. We're going to have $10,324.52. I'm going to go ahead and figure out what my interest is so I can compare interest with interest, okay? So the interest on this account is simply just going to be $324.52. So out of the first two options, it looks like the savings account is going to give me back less interest than Uncle Joe promised me. Now, the cons to when Uncle Joe is saving my money, that I don't know what's going to happen with Uncle Joe. Do you trust Uncle Joe? How's Uncle Joe's health? Is he going to be around for a long time? So there are cons to getting your money to Uncle Joe because that's a personal loan. It's not guaranteed. Where with a savings account at a bank, it is guaranteed, but it does look like it might give you less money. Now, after savings accounts, your next highest option would be CDs. CDs is just like a savings account, but you do have to lock your money in for a certain period. You can buy 6-month CDs, yearly CDs, 3-year CDs, things like that. And it's basically they give you a certificate that you put this money into their account, and in return, you'll get the certificate, and then you're letting them hold onto your money for a certain period of time, which you dictate. So it looks like you went and bought an 8-year CD. So you're saying to the bank, go ahead, hold my money for 8 years. And in return, they're going to give you a slightly higher return rate than they would with a savings account. So let's go ahead and figure out what our future balance would be. We're going to use the same formula. So we have our principal of $10,000 times 1 plus our interest rate. But we're going to compound this quarterly, which means 4 times a year. So that's going to be raised to the power of 4 times 8. So we're going to put that into our calculator. We're going to figure out what our future balance will be. So our future balance is going to be $10,449.51. So you can see in interest, I have earned $449.51, which is definitely at least more than the savings account. So CDs will always yield a slightly higher interest rate. But again, you're letting the bank hold on to your money for a certain period of time, and it's not accessible. The last option is going to be a money market, which is also stocks. If you're going to get into stocks for the first time, the recommendation is you get into some sort of a stock where it's a money market. In other words, it's a mutual fund that has many stocks wrapped into a nice portfolio. They'll take like the top 100 tech companies or top 100 sports companies or whatever you want to get into, and they'll take the top 100, put them all together, and then they diversify to all 100. So that way, in case one business tanks, you're still going to be kind of coming out even because you have 99 other businesses that will pull you through. So a lot of people get into that. Now, it doesn't give you the highest interest rate because you are diversifying into 100 different companies. They all kind of balance out. If you're looking to make money quick, you would want to get into maybe 1 or 2 businesses, but that's also very risky. So this is another option, and they do cannot guarantee a certain rate like CDs and savings bonds, or excuse me, like CDs and savings accounts can, because these do go up with the market. Every day you can check your for example, like the Dow Jones, you can check your annual percentage rate to see if it has went up or down from the previous day. And these are good for things if you want to save for longer periods of time. If you're looking to just put money in today and taking out tomorrow, that might be a big risk because the interest rate tomorrow might be lower and then you've lost money. So money markets are a good way. A lot of people that save for retirement usually put their 401ks into some sort of mutual funds. So we're going to figure out, again, we're going to though compound continuously on this account. So my equation, we're going to use the PERT formula because it is compounding continuously throughout the day. So the original $10,000 is going to be multiplied times E to the R times T power, and we're going to figure out what this account is going to give us in the end. It looks like this account's going to give us $12,917.53. So you can see the amount of the interest that I will earn in total. It's going to be $2,917.53. So out of all of the three accounts, you can see that the last one does look like it'll give me the most money other than the simple interest. But again, that's very, very risky because I don't know if I fully trust Uncle Joe to give me my money or not. So if you want to guarantee, then I would probably go with that last one because it does give me the highest amount of interest over the long course of these three other accounts. Okay. So also another way you can compare accounts, instead of actually finding out the interest earned on every single account, one way to do this is also find the effective rate of interest. So now the effective rate of interest is just going to be the simple interest rate that would yield the same amount as the compounding interest would. The effective rate of interest is an investment that earns an annual interest rate. So what we're going to do is on the previous page where we had all of these that we've already done, we're going to figure out what the simple interest rate would be for each of these so we can compare them by just looking at the interest rates. We can't really compare this interest rate, for example, to this interest rate because this interest rate is compounded differently than this interest rate. So what the formula on the next page will do is it will take into account the compounding periods, and then we'll be able to compare those interest rates to see how equal they are. So let's look at the previous four examples and recalculate all those scenarios from the previous one and find each of their effective rates. Now, the effective rate from the first example is simply just going to be whatever that interest rate was. So for example, for number one, since this already is simple interest, then the 4% is going to be the actual effective rate. Okay, so the effective rate for the first example is simply just going to be 4% because it's already in simple interest form. This is already simple, so we don't have to convert it at all. Now the second one is a compounding interest, so we will have to convert it. We'll use this formula up here to convert it back into simple. So the effective rate of interest is going to be 1 plus the interest rate, which was 0.004 over the compounding periods, which was annually. And we're going to put that into my calculator. And you're going to get 0.004, which is equal to 0.4%. So you can see, obviously, that is much lower than the simple interest account was. Now, that number actually does match what I had on the previous page because we only compounded one time for the year. So if you were going to compound more often, that number would increase because the more often you compound, the higher that number becomes. So if you're going to compound only once a year, the interest rate actually is the simple interest rate. Now for the third one, our effective rate is simply going to be 1 plus the interest rate. But we're going to divide that by the number of compounding periods. I believe it was quarterly. Yes, it was. We compounded this account quarterly. So I'm going to put that over 4 raised to the 4th power minus 1. So we're again going to calculate this just like we did the last one. Now I'm going to expect my effective rate is going to be slightly higher than 0.55% because we are compounding more often than just once a year. So it looks like we're getting an interest rate of 0.005511, which is 0.5511%. So you can see how the 0.55% has now risen to 0.5511%. And that's because of the 4 times a year compounding. So it is an effective rate that is higher than what we started with. And lastly, let's move on to the last example, which was continuous compounding. Now, the effective rate for continuous compounding does have a different formula, which was written up above. So the effective rate of interest for continuous compounding is written by the following. And the number 4 from the previous page is interest rate was 3.2%. So let's go ahead and write in e to the 3.2% minus 1. So we're going to put that into my calculator here. And we're going to get an effective rate of interest of 0.032517, which is 3.252%. So you can see how the 3.2% has now become 3.25%. So the effective rate definitely increased more by continuously compounding this account. So if I looked at all 4 of these, you can see the one that has the highest effective rate was going to be, if I were to rank these in order of which one was going to give me the most money, this one would give me the most money. And then second would be the continuous compounding. Third would be number 3. And last would be the savings account, because it only has an effective rate of 0.4. So ranked in order of which one was going to give me the most money, it would go 1, 4, 3, 2. And when I flip the page over and I look at how we did the previous 4 problems, you can see that that also is true. The one that gave me the most money was the first, then the fourth, then the third, and then the second. So it's just another way of calculating which one will indeed give you the most money without having to calculate the whole end result or the future balance. You could just simply calculate the effective rate of interest. So they're all in terms of one type of interest. Because you can't compare continuous compounding with regular compounding or with simple, because they're all different types of accounts. Okay, the last thing we're going to talk about for this section is present value. Okay, so for this last example, we're going to talk about present value. When people in finance speak of the time of money, they're usually referring to the present value of money. The present value of $8 to be received at a future date is the principal that you would need to invest now so that it will grow into $8 later. So for example, you know you can secure a savings account at, let's say, 5%, and you know you need a new roof on your house in, let's say, 6 years, and you want to put some money in the account, watch it grow, so you'll have exactly $10,000 in 6 years. Well, how much would you need to put in that account today so you'll have $10,000 in the future? So the present value account is really useful for figuring out, bringing back some future value back to today and letting you know what you would need to save today so you could have that amount in the future. So that's what this example is going to do. There's 2 ways you can do this, using either compounding interest or continuous compounding interest, either way. But it's basically just taking the previous equation and rearranging it. So instead of having A equals, in other words, your future value equals the principal, which is what you start with, this one's rearranged. This one says, here's the principal we're trying to start with, given the future value in the future. So we're just rearranging the A and the P by rearranging the equation, doing some algebra and some manipulations of those exponents. So let's do just one example. Let's say you recently went through a divorce and your soon-to-be ex's future retirement pension will be worth $1 million 10 years from now. So your ex plans to retire in 10 years, at which point they will receive $1 million from their pension. You're asking for half of everything. And so you need half of that future pension, but you're not going to get half of that 10 years from now. You're going to get half right now of what the value of that $1 million would be right now. So we got to bring that $1 million from the future back into today's value. What would this $1 million be worth today? In other words, how much money would you need to put into an account right now today, so that way in 10 years you'd have this money in the future? So we have to figure out the present value of that money. So we're going to assume for this particular account, let's go ahead and assume, since it doesn't give me enough information, let's assume we can secure 2.8% compounded monthly. So let's say that that is a safe assumption. That is something that you'll need to work out with the current economy, with your lawyer, to decide if that's a comfortable assumption of what you could save for. So we're going to use the compounding interest formula to find the present value. So we're going to take the future value of this account, which is $1 million, times 1 plus the interest rate over the number of compounding periods to the negative 12 times the next 10 years. Remember, we're going to save this for 10 years. So we're going to figure out exactly how much this $1 million would be worth today, 10 years prior to its maturity. So let's go ahead and find that in my calculator. So let's take the future principal, which is $1 million, which is 1 plus 0.028 divided by 12 to the power of negative, oh, that's not a negative, negative 12 times 10 power. And you'll see that that $1 million is worth $756,000 right now. So this is how much money that $1 million would be worth right now. So when, again, in other words, if you put in $756,000 into an account right now, saving 2.8% compounded monthly for the next 10 years, you're going to end up with exactly $1 million 10 years from now. So this is how much the present value of that future retirement would be. And since you're requesting half, we simply just have to divide that number by 2. Oops, go back. So you're requesting a total of $378,015.14. And then, of course, if you were to then receive that through the divorce proceedings and you saved that at 2.8% for the next 10 years, you'd have exactly $500,000 in 10 years, because you would expect exactly half of that 10 years from now.